In the last lesson, you and Mrs. Milburn worked out what would a $2,500 investment at a nominal 4% rate per year over a period of 6 years be worth if you compounded it in different ways. And for that, you just kept adapting the general growth formula. Now you'll see this general growth formula in many guises. One of the more popular ways in the financial world is to rewrite this as A equals P times 1 plus R to the T, where A is the future amount, which I'm having trouble spelling, and P stands for the principal, or sometimes they think of it as the present value. It's the same old formula, just looks a little different. And I'm sure you noticed as you were doing this that the more times you compounded it, the higher the total value was worth at the end of the 6 years. So you would expect that if you compounded it weekly, after 6 years you'd have more. If you compounded it daily, which is how most of our credit cards compound our debt, you'd have more value. We could compound it hourly. We could compound it by the minute. We could compound it eventually continuously. If you recall, using the growth formula, when we had to compound it monthly, that meant we had to take the rate, that was a yearly rate, and divide it by 12. We had to take the time, which was in years, and multiply that by 12. If we keep doing this for weekly and daily and hourly, the formula becomes quite ferocious. However, for things that are compounded continuously, the formula is not too bad. Compounded continuously means that the amount we end up with is going to equal the principal times the natural growth factor E raised to the R times T. And that's it. That's the whole continuously compounded formula. In this case, then, the amount we end up with is going to be our principal, our original $2,500, times E raised to the rate, and the rate is still going to be written as a decimal. I'm going to put 0.04 in there just for, and then times, that's 4% per year, times 6 years. You can put it in the calculator like that. I'm going to save a little bit of fingertips here. This would be E raised to the 0.24. And we can just go ahead, ask the calculator, come up with an answer. So to the nearest cent, my calculator said that the investment, if compounded continuously for those 6 years, would be $3,178.12, which is a little bit more than compounding it monthly or weekly or daily or hourly. Let's try another one. Suppose we have $50,000 invested at 5%, compounded continuously, for a period of 18 months. So because it's compounded continuously, we can use the little formula that the future value is going to equal the present principal times E raised to the RT. We still have to be careful about our units, though. This is assumed to be 5% per year, the nominal rate. This is not 18 years. We are not going to do, it does not equal P times E to the 0.05 times 18. It does not equal that, because that would mean 18 years. 18 months is not 18 years. 18 months is 1.5 years. So we still have to be careful with our units. So readjusting with the 1.5 years, the amount it's going to eventually be worth will be the original 50,000 times E raised to the 0.05 times 1.5, which you could put all in the calculator. We could, if you're good at doing math in your head, we could say this is times E to the 0.075, and then ask the calculator for that. Mine came up with a future value being something like $53,894.21. Don't want to forget the 21 cents. So now would you please check out the next slide where you have a problem to try on your own. And when you finish that, move on to the next video to see whether or not you're correct.